Hi, my name is Niklas Kunkel, and I'm the founder of Chronicle. And today I'm going to be telling you about a topic very near and dear to my heart called Don't Trust, Verify. Kind of giving you an introduction to Chronicle and what we're all about and how everything works kind of under the hood. So you've probably never heard of Chronicle. But you may know us by another name. So we actually used to be part of the Maker team. I personally was part of the founding team of Maker back in 2017. And at the time, you know, the ecosystem was fairly undeveloped, and we had to kind of build a lot of stuff from scratch that kind of just didn't exist at the time. So we actually built the first decentralized exchange on Ethereum. So some of you may remember Ether Delta. We actually preceded that by almost 8 months. And also a little known fact is at Maker we developed the first oracles on Ethereum. So we've actually been live since June of 2017 on Ethereum mainnet in conjunction with Psi, which was the kind of precursor to the stablecoin DAI that you probably all know and love. And so, you know, we've been live for 6 years now, you know, never been hacked, never gone down or gone offline. And so this actually makes us one of the longest continuous running protocols, not just on Ethereum, but actually in all of crypto. We back in June, we just hit 6 years, and we're quite proud of that. So what have we been doing? Well, up until recently, we've effectively just been the oracle for MakerDAO since its inception, right? And through the ups and the downs, right, during the bull market, at one point we were securing almost $20 billion. Currently, there's about $6 billion of TVL in MakerDAO, and we secure all of those assets. And that actually makes us the second largest Oracle provider in terms of assets secured behind Chainlink. So, in order to tell you what makes Chronicle so compelling and what makes Chronicle different from other Oracle protocols, we kind of have to look at the Oracle landscape a little bit and identify the problem space. So for many of you, the way that you've come to view an Oracle is probably very similar to this. There's a smart contract somewhere, and it just has an asset pair and this price, and you're like, great, that's an Oracle, right? But this is actually really broken. Because you have no kind of understanding of where did this data come from, right? How do you know this data is correct? Where was the data sourced from? How was it transformed? What guarantees do you have that this data will continue to be there, right? We spent, as an ecosystem, we spent on the order of hundreds of millions, if not billions of dollars developing blockchains, right, that are decentralized and transparent. And then we spend another order of magnitude of money, right, on building applications on top of those blockchains that are decentralized and transparent. Yet, for some reason, on the infrastructure front, we just kind of are content to just have everything be this black box. And now we have this opportunity to kind of go back and do things the right way. So, what else do we have? Here is what an Oracle update looks like on Etherscan, and you may notice that it is extremely expensive. Oracles have one of the highest kind of transaction frequencies in terms of how much block space they occupy, out of compared to most apps outside of maybe something like DEXs or perpetual protocols, just because they update so frequently. And this is even more kind of potent in times when gas prices are high, right? So gas prices tend to be quite low relatively at the moment, right? I think right now we're at around oscillating between 20 and 30 gwei. Occasionally we'll hit like 200 gwei or something. But if you remember, even just like a year and a half or 2 years ago, I mean, there were points where we hit 7,000 gwei, right? So imagine trying to manage, the kind of update costs, for an Oracle when, your costs can just multiply, from like a 20 gwei to like a 7,000 gwei, right? And so current Oracle kind of solutions, they don't scale. They really don't. And so we end up coming up with these kind of like Band-Aid fixes for kind of trying to cover up this flaw on the engineering side, right? So one solution that we frequently see across many Oracle protocols is that you just start updating less frequently when gas prices are very high, right? Sure, you'll spend less gas, and by proxy less money, but degrading Oracle performance to save on Oracle costs is not really a viable trade-off, right? Similarly, you may hear some Oracle protocols talk about, pull oracles, right? And, that this is great, right? Well, great for who? Someone still has to do the Oracle update. And with pull oracles, you're just kind of kicking the bag and passing the buck to the end user. And, the end user may not notice now when gas prices are low that, every transaction they do on the protocol, right, has an Oracle update bundled in. But when gas prices start to rise again, which they inevitably will, it's just going to be more and more painful, right, for users to have to be responsible, right, for pushing these Oracle updates, right? And so what you really need is like an actual engineering solution here, not a product marketing type of solution. So what we've been working on at Chronicle is called Project Scribe. And we're almost ready to unveil it to the world. And we kind of had several kind of properties of Scribe. And so if you take nothing away from this talk today except one sentence, I want you to take away that Chronicle is a decentralized Oracle protocol that is 1, verifiable, and 2, scalable. And we'll go a little bit into each one of those areas. So let's talk about decentralization. Most Oracle protocols use validators, right? Some call them by some other name, right? Node operators, nodes. In Chronicle lingo, we call these feeds. And so we've built up kind of this ecosystem of feeds, of highly reputable participants in kind of the crypto community. And we really, this is a core kind of part of the protocol, right? When you think of like, an Oracle protocol, what you're trusting is not necessarily the Oracle protocol itself, but this sample size of, feeds, of validators, of node operators behind the protocol. And, while some Oracle protocols are very, forthcoming with these are our validators, others just ignore the question completely because it's not a happy answer. So at Chronicle, we've kind of assembled this network of highly reputable feeds. And, as a user of an application, right, that uses a Chronicle Oracle, what trust assumptions are you making? Well, as a user, you may already be using MetaMask every day, right? And so you're implicitly using Infura. You may hold some DAI in your wallet, right? You may have an Argent mobile wallet on your phone. You may have a Gnosis safe, right, to store all of your assets, right? And you may swap on, Matcha. So you're already implicitly trusting many of the same protocols and applications, right, that are validators for Chronicle. And you're not trusting any one of them individually, right? You're trusting the consensus between all of them, right? And so as more and more kind of highly reputable feeds kind of come online that are essentially staking their reputation, the Oracle just gets more and more secure over time. So here, for example, is a list of the feeds, right, in action. I actually took this screenshot last night. So this is a pretty accurate rendition of what you'd see if you take a look at our dashboard. Right, and so you can see like every second, all of these feeds are just constantly pushing and attesting to different price updates for a bunch of different asset pairs that we support. So I want to talk about verifiability, and this is an extremely important property of Chronicle that I think is quite unique compared to other Oracle protocols, because I think it's going to help us break out of this like broken paradigm of oracles and hopefully infrastructure in general in crypto being this black box. And so how do you define verifiability? Well, I like defining verifiability as transparency plus legibility. Now, what do I mean by that? Well, most crypto protocols will say, well, we're on a blockchain, we're transparent. But transparency isn't really useful without legibility. If the only one that can interpret an application, right, is some kind of senior Solidity developer or some kind of professional Nansen analyst, right, we've really lost the plot, right? Because we're not really exhibiting don't trust, verify. We're just kind of trusting everyone else, right, to do the due diligence. And so a big focus for us, right, is how do we design the Oracle protocol around being end-to-end verifiable? And that means that everything you see on chain, right, from this canonical Oracle value can be traced all the way back to the source data. And every transformation of that data is can be illustrated in a very easy to understand way. So I want to kind of walk you through our dashboard to show, like, because I think show don't tell is way more illustrative of this concept. So here we have an ETHUSD Oracle, right? And you'll notice, right, the price is 1662.72. This was, I think, taken, I believe, like a week ago. So for any update that the Oracle has done, you can see the exact feed, kind of price attestations for that update. Right, so right here we have Argent and DeFi Saver and MakerDAO and Etherscan and 0x and a few other feeds where we haven't quite mapped their name to their address yet. And so now you can kind of see that, oh, well, that 1662.72 value that we talked about earlier, right, is we got to this value, right, because this feed was the Schelling point kind of consensus among 13 different feeds. But, how do we know, it's great, fine, this feed attested to that piece of data. I get why the Oracle says the price it says based off all the different validator responses, but why did this validator, why did this feed, come up with that price? And you can see that too. And so here you can see that, well, Argent came up with their 1662.70 price, because they queried ETHBTC from Binance, they queried ETHUSD from Coinbase, from Bitstamp, from Kraken, from Gemini, and then they got the BTC USD price from a bunch of places to convert the Binance price, right, to a USD kind of quote price, right? And so you can see the exact raw data that the feed used when composing, its own price attestation. And so the best part is that this is actually all cryptographically verifiable. So the feed can't lie, and you don't have to trust the dashboard to not just show you a rosy picture of the data, because you can actually do the same cryptography that the smart contract does, but locally in your browser. So next to Argent, right, there's this really nice verify button. Right, and if you click on this nice little verify modal will pop up, and you'll see that this attestation includes, right, a value, right, the data value. So that's, in this case, that's the price, right? Which piece of data, that's ETHUSD, right? A timestamp and the corresponding signature. And if you click verify, you'll run the verification to decrypt the message, right, and verify, yep, this feed actually signed this exact price attestation. If you were to change, say, the timestamp by 1 second, so on the right-hand side, we reduced the timestamp by 1 second, and you tried to verify it, right, now you see that there's an error, right? This feed did not sign that message. That message has been tampered with, something is going on. So the last kind of property I want to talk about is scalability. So, I kind of alluded to heavily at the beginning of the presentation, right, that costs are an enormous factor right now among kind of Oracle protocols and among their sustainability going forward. So what we've come up with to kind of address this challenge is what we call an optimistic Schnorr algorithm. And what we found is that compared to our previous algorithm, which was already very competitive with kind of current Oracle implementation gas kind of rates, we discovered about a 66% gas improvement, which is, incredible. And, we think there's like a little bit of room left for improvement, but we're really getting near kind of the limit of what is possible. So before I get into the implementation itself, I wanted to talk a little bit about what our goals were with this implementation. So one, we wanted to have a single implementation across all blockchains. We don't want to say on layer 2 or on an optimistic rollup have one implementation, the ZK rollup have another implementation, on ETH layer 1 have another implementation, and on Polygon have a different implementation. One that's incredibly resource intensive to manage, and two, it's incredibly insecure when you're trying to focus locking down all of these different implementations and porting features across all of them in blockchains that have completely different kind of characteristics. Two, we wanted to decouple the Oracle update gas costs from the number of feeds. So another kind of trick that a lot of Oracle protocols use is say like, well, if we used a lot of validators, the Oracle update would get too expensive. So we're just not going to tell anyone and just use very few validators. I don't know what you all think, but that's also not a very viable solution. So we wanted to, decouple this and ensure that, there wasn't a linear increase in gas costs anymore as you increase the number of validators. And third, of course, right, we wanted to minimize the gas costs, right, for updating this Oracle. So some of the obstacles we ran into, right, L1, very different properties from L2. Compute is very expensive on L1, call data is very cheap. On L2, the exact opposite problem, compute is cheap and call data is expensive. So how do you go about creating an implementation for both? And the second challenge is, well, EVM compatible chains actually doesn't mean that they have EVM equivalents. And just because there is a very nice precompile on Ethereum that you can use or that is going to be in some future hard fork, you have very few guarantees that your very nice precompile will ever exist or may exist in the future on some other chain. So effectively that means you need to roll your own. You cannot rely on precompiles. So I've been told I have 1 minute, so I'm just going to kind of speed through this really quick. But if you, I'd suggest you take a picture of this slide. What we're doing is essentially validators will create a aggregated Schnorr signature, right? So instead of X feeds creating X signatures, they're now just creating a single aggregated signature. Unfortunately, that single aggregated signature is still very expensive to verify. And so what we do, and what makes us optimistic, is that we have a single feed sign on top of the Schnorr signature, and then a relay, right, will just push the Schnorr signature, the single kind of attestation to the Schnorr signature, and the price and timestamp on chain. What this does is the Oracle will just verify the single signature attesting to that the Schnorr signature is correct, right? And so that's what makes this optimistic. And so now we start this kind of challenge period. During this challenge period, anyone can just call this challenge function, and all it will do is actually just spend the gas verifying the Schnorr signature, and if it's successful, the challenger, right, gets to claim the ETH. So we kind of saw like a 66% gas improvement here, right? So from 138,000 gas down to 66K. And I'm very excited to tell you all that we are launching next month on September 13th. And very excited to talk to all of you and get Chronicle integrated into your protocols. So please get in touch with us. We're hiring for a DevRel role right now, as well as a technical project manager. So you can reach out to us at hello@chroniclelabs.org. Check out our website, check out our Discord, and follow us on Twitter. Thank you.